Okay, so today we're gonna take a look at integration by parts. So let's say you come across an integral that looks like any of these three up here. And at first glance, it would appear that there's no easy way to do these. I mean, this one just, you don't even know where to begin. You could take a u sub for these two. I don't recommend it. I mean, there's really not much of a u for this one. And unfortunately, there's no addition, so you can't break them up, and there's no product rule for integrals. So, this is where integration by parts steps in. And the way to do that is you have this really nifty little formula here, which is the integral of u dv is equal to uv minus the integral of v du. And you'll be thinking, well, okay, that's cool, that's great, but what does this exactly mean? What's u, what's v? Well, we'll go ahead and take a look at that, and the best way to do so is just go ahead and do it by example. So we're going to pick the one up at the top here. I already have it pre-written down. And so the way you begin is you're going to pick what you want to use for your u. And with this example, you could really pick either one of these to be your u, but we're going to go ahead and do x just because it's a little bit easier to deal with. And get in, there you go, get in the equation. So u would equal x. And of course, du is basically the derivative, so derivative of x is just 1. And then your dv is whatever's left over from your u, so that would be e 5x dx. And finally, your v is the derivative of your dv. It's the integral of your dv. I'm mixing up my words here. So, for that one you get 1/5. And you don't have to worry about putting a c in, that's just not something you do. And so once you've got all that, it's just a basic plug and chug here. So go up here to the equation, plug all that in on the right side. Let's go down here. Not that far down. There we go. So you have u, v, minus the integral of v du. Alright. And after that, it's just real simple integral. I forgot the equal sign. Always good to put equal signs. Helps your equations flow better, helps them read better. I personally won't count off if you forget an equal sign, but some people do, and honestly, it's a really good habit to get into. So, I don't count off because I know I forget them. So, then just go ahead and keep going here. Let's go ahead and take that constant out. There you go. Getting a little ahead of myself here. Okay. No. No, there you go, it's a lot better. Alright, and there you go, that is your final answer. Now another interesting one to take a look at for integration by parts, this would be the third one right up here. Scroll back up here. There we go. It will be this one up here, because it doesn't look like it's, it's not being multiplied by anything, but this is still integration by parts problem, and let me show you what I mean by that here. There we go. Oops, if you hit the right buttons on your keyboard. Alright. So you're looking at it maybe going, well, how's that integration by parts? There's no second part, there's nothing there, it's just one single thing. Well, handy little trick you can do here is just go up and add a sneaky little one. And bam! And because I mean, technically that one it's there, it's just implied. So let's go ahead and plop in a one, and then after that, and I am banging my chair. And you can go ahead and you can go ahead and work out your integration by parts. So u equals. Of course, of course, it may be easier to take the one as your u, but in this case, you're going to want to take the natural log because, I mean, you could try to put natural log as your dv, but then you have to end up taking the integral of that, and that's kind of what we're trying to find. So, would not work very well. Right, so there's your u. I'm going to move that down a bit. Always running into this problem. So yeah, don't do that to me. Okay, so there's your u, and then your du, just 1 over x. There we go. Then your du, then your dv is just 1 dx or dx. Then your v would be, and of course the integral of 1 is just x. Then once that's done, same old song and dance, plug everything back in. So that would be x, natural log of x. Technically you're supposed to do natural log of x times x, but this just, I should do this way because it looks nicer. Minus integral of x times 1 over x dx. Of course, you can, of course, the x is right here. There we go. Because you can't see my finger. The x is right here is going to cancel each other out, so it's the integral of 1, which just leaves you with, again, it helps if you can properly type. And there you go. So yeah, whenever you see what looks to be a single variable just by itself, go ahead and just plop a 1 in there and that'll get you started. And another thing I want to talk about before we go on is tabular integration. Now tabular integration, don't slow your words. Tabular integration is a really handy way for dealing with repeating integrals. So basically, let's say that you have something that looks like 2x, 2 squared plus 5x minus 11 times. And you could just do regular integration by parts, and truthfully there's no reason you can't. The only problem with this is, since you have that squared up here, you'd end up integrating it twice. And honestly, that's just, these things take long enough. Tabular integration is a way to streamline that and make it go a lot faster. So what you do, let's go ahead and insert a little table here. Just doing table because it's Word. It's a very handy tool. And the column on your left is what you're going to differentiate, so basically your U column. The column on the right is things you're going to integrate, so this is kind of like your V column. I cannot type today. I really cannot type today. There we go. Alright, and so you're going to take your U, which is this little equation the equation on the left. So 2x plus 5x. Then you just go down, take the derivative of that. 2x squared, not 2x to the x. There we go. Then you just go ahead and go down the line, take the derivative. 4x plus 5, 4. Of course, derivative of any constant is just 0. And once you hit 0 in your left-hand column, you can just go ahead and stop, because there's really, I mean, derivative of 0 is 0. There's really no point going on just with an endless string of zeros. You're going to be here forever. So once you hit 0, you go ahead and go into the right-hand column. Take your v, which is e to the 2x. And it really helps if you hit the alt equals first. Learning that more and more every day. Then you just, take the integral from there. Ah, there it is. Scroll bar blends in with things too easily. Alright. And once that's done, now usually what you do at this point is you draw a little diagonal line connecting this one, this to here, here to here, here to here. But, well, that's Word and it won't let me do that. So, yeah. And another thing I cannot talk. Another thing here to note is that this actually goes into patterns, where you have this one is positive, this one is negative, this one is positive, and so on and so forth. It just goes in a pattern. And of course, it's a lot better if I actually write it out instead of trying to talk it out and confuse people in the process. So, just go up here. Of course, this is just an endless string of UV. So what am I doing? I forgot what I was doing. Minus plus, no, 4, not 1, times 1/8. Which, of course, you can multiply this one through. Just gonna see if I can't copy this. See if it'll let me. And it will! Yay! 4 divided by 8, which is 1/2. And there you have it. That is tabular integration. As you can see, actually, let me just go add a couple parentheses here. Extra parentheses. Probably unnecessary, but yeah. So yeah, as you can see, tabular integration makes this a lot easier, because if we would have done it, the traditional way, we would have actually ended up doing this twice. Which isn't that big of a problem, but it can stretch out for just a long period of time. And let's be honest here, no one wants that. Math equations are long enough. But yeah. So as you can see, integration by parts, whether it's tabular or just, the normal UV minus integral VDU, it's really simple stuff. It's just all plug and chug, really. So nothing too much to worry about there. And that is done. Thank you for listening.